Projectile motion is a form of motion where an object, called a projectile, is thrown at an angle and moves along a curved path under the force of gravity. To demonstrate projectile motion more clearly, I will be using the physics behind punting a football as an example. When it comes to projectile motion, there are three important aspects of physics that come into play. The first two are energy and forces. A football starts off with potential energy of gravity in the player's hand, then gains kinetic energy or motion as soon as a player touches it with his foot and puts a force on it. When the football is flying through the air after being kicked, it follows a curved or parabolic path, since the movement of the ball in the vertical direction is influenced by the force of gravity. As the ball travels higher and higher, the kinetic energy goes down as the potential energy of gravity goes up. The velocity of the object goes down as well. The gravity slows it down until the very top, where its acceleration is 9.8 meters per second because it's in free fall. Then it comes back down, gaining more and more kinetic energy as gravity makes it accelerate until it touches the floor. When it comes to the third side of projectile motion, the x and y axis, the ball moves in two directions. It moves vertically and horizontally. This is because the ball was launched at an angle. How fast and how far the ball will go depend on the angle of the launch. If the ball is kicked at a steep angle, it will have more velocity in the vertical direction, go higher, and travel a shorter distance. If the ball is kicked at a lower angle, it will have more velocity in the horizontal direction, go lower, and travel a longer distance. This is why the optimal launch angle for a projectile is 45 degrees, right in the middle. It gets an equal amount of both horizontal and vertical forces.